Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question construct binary tree from post order and in order traversal. So we will be given the post order and in order traversal, and we need to construct the binary tree out of it. Okay, so let us discuss. See, we will be given the post order and in order. Let me recall the property of post order. So it is left right root and it is left root right. So this indicates in post order there are the elements of left subtree, then there are elements of right subtree, then at the end there is the root value. And in left and in order traversal, firstly left subtree, then root value, then right subtree. Okay, so we'll use the property of post order, that it is fixed that the last value at 11th index, this will be the root value, and this root value we will find in our in order traversal. And if we'll get this value in our in order traversal, then this indicates this part from 0 to 6 is our left subtree and this part is our right subtree. So firstly we have found the root from post order, and that root value we have searched in our in order traversal, and at that index where we have found that root value, before that all elements belong to left subtree and after that all elements belong to right subtree. Let me ensure this thing. So in left subtree there are elements 1 3 4 1 3 4 7 8 9 10 7 8 9 10. Okay, so all elements are covered in our left subtree. In right subtree 2 5 6 11. So 2 5 6 11. Okay, so this thing is ensured over here. Now what we are going to do is we'll think of its approach. So this thing we have discussed, we have searched for 0, and we will make recursive calls for left subtree and right subtree, and talking about our expectation and faith when we'll have our root value, then what this will do, this will call its left subtree, that go and make your binary tree, and it will make call to its right subtree, and it will say go and make your right subtree, and after that it will attach its left subtree to its left side and it will attach its right subtree to its right side. Okay, so this is how it will be done. So the first thing is we'll take some variables. See, this is the post order, this is the in order. So for post order we'll take a starting index, and for in order we'll take a starting index, post order ending index, and in order ending index. So what we'll do, this post order starting index will contain 0, this will contain 0, this will contain 1, sorry not 1, this will contain 11, and also this will contain 11. Okay, so how we will do this thing, we'll also, what we'll do, firstly we will take the root value out of post order traversal, since we know that the last element will be the root element. So we will compare with the post order of PEI. Okay, alright, PEI will have 11, and we'll compare this value with what? We'll mark an IDX value, we'll initialize it with what? ISI, and we will make it move to all these elements. Till when? Till it got the value of post order of PEI. Post order of PEI is 0. So till it gets 0, it will search in this in order array that where is 0. So it will find the 0 at 7th index. So what we'll do, we'll create a while loop. it will search in order of IDX till the point it is not equal to 0. It is not equals to post order of PEI. Till then IDX will be increased and we will stop at the point when we find the root value. Okay. So till now what we have achieved, we have got the root value. We have got the root value in our in order. This is the first step which will differentiate the left subtree and the right subtree. Okay. So now what next? See, when we have found this root element, this IDX will be 7. Okay. And the next thing is, we'll count the number of elements in our left subtree. So total number of elements will be this. See, if we want to calculate the numbers from 7 to 12, excluding 12, then formula will be 12 minus 7, that is 5. So same thing is here, we have to calculate the number of elements between the range 0 to 7, excluding 7. So formula will be 7 minus 0. So IDX minus ISI. Okay. So this will be formula for finding total number of elements. What next we'll do? PEI. So now we have found the IDX and we have found the total number of elements. Now what we'll do, when we'll make recursive calls to left subtree and right subtree, we'll pass some values. So we will create some variables. What kind of variables? See, in the left post order and in the left in order. In the right post order and in the right in order. Okay. So what we'll pass in, we'll pass these values for now. Just forget about these things. First focus on the over here. When we will find this IDX, then what we'll see that this 7 differentiates this in order into left subtree and right subtree. Then we'll find the range of this. Okay, so range will be what? Range will be, this will be IDX minus 1 for left. First we will see for left post order. So for left post order, see, this is the point where we have got our IDX, where our root. So this will be our right subtree and this will be our left subtree. Okay. And if we'll see over here for post order, till here only, where we have till where we have the range of in order, that range will be also for post order. How this thing we'll see. This will be left subtree and this will be right subtree for post order, left subtree and right subtree for in order. Okay. How? Just match this thing. 7, 3, 8, 1, 9, 4, 10 were the left subtree elements, and in post order 7, 8, 9, 7, 8, 9, 10. Okay. 3, 4, 1, 3, 4, 1. So this proves that this is the left subtree for in order and this is the left subtree for post order. Okay. So now work for the ranges. What will be the ranges? So for left subtree, the range will be post starting index. Okay. and the ending point will be, see, till here total number of elements are 7. So post order index will denote that the ending range is post order index plus total number of elements. So this will be 7, but our index is 6, so this will be -1. So post starting index plus total number of elements -1. Okay, so this will be range for left post subtree, and for left in order subtree the range will be starting from ISI in order starting index till IDX -1. Okay, for right post subtree the ending was PSI plus total number of elements -1. So this will be PSI plus total number of elements, and the ending range will be PEI -1. Okay, now for right in order subtree range will be IDX plus 1 and IEI. Okay, so these ranges we have found. Okay, so till now we have achieved these values, these ranges for left post order, left in order, right post order, and right in order. Now what is left for us? We'll try to figure out the solution. How? See, we'll be also drawing the stack diagram for this. Okay. So what will pass? We'll pass PSI, post starting index, post ending index, and in order starting index, and in order ending index. Okay, and what else? These 4 things. Okay, so firstly, initially PSI value will be initially PSI value will be 0, PEI will be n-1, which is 11. Okay, ISI will be 0, IEI will be 11. Okay, and we'll make left call. And also what we'll found, we'll check this condition. Okay, let me erase this thing. So now we'll make calls, and just after this, one more thing we'll check total number of elements, IDX minus ISI. Okay, so initially total number of elements I am writing over here. Total number of elements are IDX minus ISI. What will be the IDX? IDX will be, while we'll iterate in the while loop, IDX value will be 7. So I am writing IDX over here. IDX value will be 7. So total number of elements will be IDX minus ISI. So it will be 7 only. Okay. Then we'll make left call. And in the left call, we'll pass what? PSI. PSI is 0. PIS. PEI is PSI plus total number of element minus 1. That will be 7 minus 1, 6. ISI will be ISI only. And IEI will be IDX minus 1, which will be 6. Then again we will make left call. And here what will be the IDX? IDX will be from 0 to 6. IDX will be what? 1. Sorry, IDX root value will be 1. IDX will be 3. Okay. And total number of elements will be, see, from 0 to 6. See, it is 1. IDX will be 3. And total number of elements will be 3. Okay. Which will be IDX minus ISI. So IDX will be 7. Which is 7 minus. Okay. So after making left call, what will be the changes? This will be PSI. This will be PSI plus total number of element minus 1, which is 6 plus 3. So here is something wrong. Total number of elements when we were calculating, this will be IDX minus ISI. ISI was 0. So this will be 3 minus 0. It's absolutely okay. Okay, so from here, what we'll do, we'll make left call. In left call, this will be PSI. This will be PSI plus total number of element, which will be 0 plus 3 minus 1, which will be 2. Okay. ISI will be 0. IDX minus 1 will be 3 minus 1. 3 minus 1 is 2. Okay. So this is left call. Now again left call is made. So here total number of from 0 to 2, IDX value will be 1. Total number of elements will be IDX minus ISI, which will be 1. Again left call is made. So till now what has been done? When we were at 7th index, then the root value was 0. When we were at 3rd index, the root value was 1. And when we were at 1th index, the root value was 3. So can we say from 0 we have made the left call, and we have created the node 1, then we have created the node 3. Okay. And here we have made left call. So this will be PSI will be 0. Then PEI will be PSI plus total number of elements minus 1. That will also be 0. Then ISI will be ISI and IDX minus 1, which will be 1 minus 1, 0. All the things will be 0. Then again left call is made. Here at 0 index, IDX is 0 and total number of elements is 0. And here root is 7. And again left call is made. When left call is made, PSI will be remain PSI plus total number of element minus 1, which will be minus 1. And the ISI value will be ISI, and IDX minus IEI will be IDX minus 1. So which will be equal to minus 1. Okay. So we should also create a base case. because we have reached a point where ISI value is greater than IEI. In rest of the cases, ISI is always less than or equal to. So we will hit the base case as if ISI is greater than IEI, then what we'll do? We'll return null value. We'll return null value, and this null value will get attached to what? To left. So this null value will get attached to, we have made call for 7, and this null value will get attached to this 7. Okay, till here. Okay, so this will be null value. Then call for right will be made. Okay, we had made for left call, then for right call. For right call, what will be done? PSI plus total number of element. For right call, firstly we'll check total number of elements and IDX, which will be 0 and 0. So then write PSI plus total number of elements, which will be 0. PEI will be PEI minus 1. This will be minus 1. This will be IDX plus 1. What is IDX is 0. So IDX plus 1. This will be remaining. Then also the base case will be hit because ISI is greater than IEI. So we'll return null, and this null will get attached to its right. Okay. So this null will get attached to its right. Now both the left and right calls are made. Both the left and right calls are made of this, and this will return what? 7. This will return 7 to its left. So this call was made from 3, so this 3 will get attached. This 7 will get attached to 3, and now right call will be made. Okay. So when right call is made, PSI plus total number of elements, which will be 0 plus 1, which will be 1. PEI will be PEI minus 1, which will be 1. And then ISI will be IDX plus 1, which will be 2. IEI will remain IEI. Okay. So here also we'll check total number of elements. So here total number of elements are 1, 1, 2, 2. So starting index for post is 1 to 1, and it is 2 to 2. Total number of elements will be 0, and IDX will be what? 2. IDX will be 2, and total number of elements will be 1. So it will again make left call, and during left call PSI will remain PSI. Then again PSI plus total number of element, which will be 1 plus 0 minus 1, which will be 0, and ISI value will remain ISI. IEI will be IDX minus 1, which will be 1. Okay. So 2 will be created. From here at index 2, 8 is created. At index 2, it is created. Okay. So from here also left call will be made. There is something wrong over here. Let me check once. Okay. So when we have made call from here, left call, then PSI was PSI. This was PSI plus total number of elements, that is 1 plus 0 minus 1, which will be 0, and ISI will be ISI. So this will be 2. This have been 2. Then IEI will be IDX minus 1. So what is IDX? IDX is 2 minus 1 1. Okay, so this will hit the base condition, ISI is greater than IEI, so this will return null, and this null will get attached to value at index 2, that is 8. So this null will get attached to left of 8. Okay, so now call for right will be made. Remove this thing from stack. For right call, PSI for right call from 1 1 and 2 2, there are 0 number of elements and IDX is 2, which is correct. Okay, so for right call, PSI plus total number of elements 1, PI minus 1, which will be 0, ISI will be IDX plus 1, which will be 2 plus 1 3, and IEI will remain IEI. So this will hit the base condition, this will return null and get attached to its right. So this will be done. So both right and left calls are made. Now this will return its reference to its right. Right call was made, so its reference to right. So this link will be made. Okay, so till here all left and right calls are made. These things are over. So from here also right call was over, so this will return reference to this. So 1 will get attached to 3. Sorry, 3 will get attached to 1. This is returning 3, so 3 will get attached to 1. So its all left right are over, its right is still remaining. Okay, so start from here. Its right is remaining, so we'll make the right call. Firstly, update these things. So from 0 to 6, in post order, and from 0 to 6 in left. Sorry, in 0 to 6 in ISI and IEI. So these values are correct. Now we'll make right call. In right call, PSI plus total number of element. So this will be PSI plus, this will be 3, and PI will be PI minus 1. This will be 5. ISI will be IDX plus 1, which will be 4, and this will be IEI will remain IEI. So this will be 6. Now left call will be made, and from 3 to 5 in, now we'll calculate from 3 to 5 in post order, and from 4 to 6 in order. So IDX will be 5 and total number of elements will be 1. So now the call for left is made. PSI will remain PSI plus total number of element minus 1, which will be 3. ISI will be ISI, and IEI will be IDX minus 1, which will be 4. Now again left call will be made. Here it will be 0, and this will be 4. This will be 4. Okay, so for left call, PSI will remain PSI, PEI will become PSI plus total number of element, which is 0 minus 1, which will be 2, and ISI will remain ISI, IEI will be IDX minus 1. So this will be 3. Here base condition will be held. This will return null. So till here 5 and 4 are, index 5 is having 4 and index 4 is having 9. So 9 and 4 are created. So firstly 4 was created. Okay. Then what is happening? Then left call was made and 9 was created. See, from 1 right call was made and 4 was created. From 4 left call was made and 9 is created. Then from 9 left call is made, and this left call has hit the base condition, so it is returning null, which will get attached to left of 9. Okay, and again right call will be made. See, when these both conditions are true, then after this step the base case will definitely hit. So for right call also null will be returned, so this will get attached to null. Okay, so both the calls are over. So now the link will be made between them to the left of 4, to the left of 4. Okay, and from now right call will be made and the stack will get deleted from here. Okay, so now right call is made. For right call, what are the updations? For right call, right p is equal to psi plus total number of elements. So this will be 4 and this will be pi minus 1, which will be 4, and idx plus 1, which will be 6, and this is iei, which is undoubtedly 6. Okay, so from here also left call will be made. Here the total number of elements will be 0. Sorry, here it was 0 and here it was 6, which was representing element 10. So that is why 10 is created. Where? From 4 right call is made. From 4 right call was made. So 10 is created, and after that from 10 left call is made. Left call is made, which will hit the base condition and will return null. So this null will get attached to its left. And then right call will be made. So this will also hit the base condition. Null will be returned and which will get attached to right of 10. Okay, so this is null and this is null. So let me draw this thing clearly. This is 10 and null. Okay, so this is 10 and this is null value. This is also null value, and till here we have completed both left and right call, and reference to this 10 will get attached to right of 5. Sorry, right of 4. Right of 4. So till here left and right both calls are completed. So this will get return reference to 4 to right of 1. To right of 1. Okay. So till here both left and right call are finished. So reference from 1 will be given to 0. So this 1 will get connected to left of 0. Okay. So till here we have completed all the left and right calls till here. All the left and right calls are completed. Now what will happen? Now the right call will be made for this. Okay. Let me remove all these things. Now the right call will be made from here, and psi plus total number of elements, which will be, these were total number of elements. So this will be 7 and pei will be pei minus 1. So this will be 10 and isi will be what will be isi? Isi will be, so this was right call. So isi will be pei minus 1. So wait a second, this was right call for post order and this is right call for in order. So it will be idx plus 1. So idx is 7, 7 plus 1 8, and iei will remain iei. So again left call will be made. So here idx value will be from 7 to 10 in post order, and from 8 to 11 in order. So idx will be 10. Idx will be 10, element will be 2, and the total number of element will be 2. Okay, so from here left call is made. Psi will remain psi. This will be PSI plus total number of element, which will be 9, 9 minus 1, which will be 8. Okay. Now ISI will remain ISI and IEI will become IDX minus 1, which will be 9. So from here also left call will be made, and here IDX value will be here 7 to 8 and here 8 to 9. So this will be IDX value will be 9 and element will be 5, and total number of element will be in left subtree. See, this total number of element are in the left subtree. Okay, so here also left call will be made. PSI will remain PSI. PEI will become PSI plus total number of element minus 1, which will be 7. Okay, so ISI will be ISI and IEI will be IDX minus 1, which will be 8. So now these both are same. It will hit the base condition, which will return null, and it will get attached to left. So here the IDX is 8, and at 8 it is, this will be 8 and it will be 11, and 11 will be, so here 2, 5, 11 were created. So initially the call was from right, so 2 was created. So there's lack of space. I am writing from after 0, I am writing over here. Okay, so 2 was created, and then 5 was created from left call, and then 11 was created from left call, and now left call was made and null is returned. Okay, so null will get attached to its left, and after the right call will get null, and then what will happen, this will or after completing all left and right call, reference of 11 will get attached to left of 5. Okay, so till now all left and right calls are completed. So now right call for 5 will be made. Okay, so this will update right of P, which will be PSI plus total number of elements, which is 8, and PI will be PI minus 1, which will be 7, and IDX plus 1, which will be 10, and PEI minus 1, sorry, it will be IEI. So this was IDX plus 1, this is IEI, which will be 11. So wait a second, let me check once again. This was right call, PSI plus total number of elements. Okay, PEI minus 1. Okay, IDX plus 1. IDX was 9. Okay, 10. Then IEI. IEI is 9. Okay, so this is 9. IEI is 9. So this will hit the base condition. This will return null. Okay, so this null will get attached to right of 5. Right of 5. Okay. Now its right call is completed. Now reference of 5 will get attached to left of 2. Now the right call will be made from here. Till then, remove these values. So while making right call, update the values. IDX plus 1, which will be 11. Sorry, this is wrong. So we are making right call. So for right call, post order PSI plus total number of elements, which will be 7 plus 2, 9, and PEI will be PI minus 1, which will be 9, and ISI will be IDX plus 1, which will be 11, and IEI will be 11. So these both values are same. So left call will be made. This is referring to 11th index. The element is 6. So 6 will be created from right of 2. So after this, base case will be head, which will be returning null values and will get attached to its left and right. And after this, left and right are over. Okay, and till here also right is over. Reference of 2 will be given to right of 0. Sorry, reference of 6 was given to right of 2. Reference of 6 from here. Okay, it's getting messy. So reference of 6 was given to right of 2. Right of 2. So till here left and right all calls are over. So remove this from stack, and reference of 2 will be given to right of 7. Reference of 2 will be given to right of 0 at 7th index 0. So this will get attached to its right. Okay, right subtree. I hope you have understood this thing. So now we will be coding for this dry run. Okay, so let's move to our code section. So what we'll do first, we'll take the size of what? Of Inorder dot length. Okay, so this will give the size of Inorder. Why we are taking this out? Because we want this 11, because we have to pass this 11 to PEI. Okay, so this will be n minus 1. What is n over here? This is 12. This is the total size, total length. Okay, so we'll create the function build tree Inorder. We'll pass Inorder and post order. Firstly, we are working for post order, starting index and ending index. Okay, so Inorder, what else we'll pass? See, also we will pass this PSI, ISI, PEI and IEI. Okay, so this will be PSI, PEI. So this is I. Inorder starting index, Inorder ending index. This is post order starting index and post order ending index. Okay, so we'll create the function static tree node build tree. So what we are passing over here? Post order and int PSI comma int PEI comma int in order of array and int ISI comma int IEI. Okay, so what will be their initial values? Means what we'll pass in the function. See, okay, so PSI will be 0, PI will be n minus 1, ISI will be 0, and IEI will be n minus 1. Okay. So now we'll make the condition, that is base case, that is ISI should be greater than IEI. If this is not true, see, if this condition is true, then return null value. We'll create a tree node of node new tree node PEI. Okay. See, now we have checked the base condition. Now there was a case when we were iterating for value of IDX. So that condition was if in order of IDX not equal to post order of PEI, till then just do IDX plus plus. Okay. Then total number of elements we have to find, we were used to find. So this formula was IDX minus ISI. See, when we were discussing the dry run, total number of elements were IDX minus ISI, and we were creating a while loop, and now we will make the calls. Okay, so we'll make the calls. So this will be this will get attached to node dot left build tree. We'll pass post order and PSI, and PEI value will be PSI plus total number of element minus 1. Okay, and next thing is we were used to pass in order and ISI value, and IEI value was IDX minus 1 while we were making call for the left subtree. Then for right subtree, build tree post order, comma PSI value was PSI plus total number of element, comma PEI minus 1, comma in order was passed, and this was IDX plus 1, and this was IEI. If you cannot recall these formulas, then just go through this ones. These are the same ranges. These are the ranges only we have passed. Okay. So now return node. So let us run the code. So there is the error of semicolon, and also we haven't initialized IDX. Okay, so we'll initialize IDX as ISI, starting index of in order. Okay, so it is running successfully. Now I'll submit, check all the test cases are passed. Okay, so it has been successfully submitted. So I hope you have understood the problem and the solution. So we'll be meeting with another video and we'll be meeting with another question in another video. So thank you for watching.